Hi, we are the group 7 and we are going to talk about laboratory experiment on beam bending. For the experimental methodology, first, we take the measurements of the beam, like length, width, and thickness. Also take the weights that will be used in this laboratory experiment. And then we make sure that the strain gauges are well connected and proceeded to put the weights at the end of the beam every 10 seconds to record our strain values in the LabVIEW software. For realize a comparison with experimental data, that is plotted in EasyPlot program and obtain a relationship between these values.
So we're gonna talk about the theoretical method for this lab. The first step was draw or plot the free body diagram of the beam, and then we can get our P of X. This P of X is using with the differential equations for beam, and then we gonna get those functions that is define the bending moment and shear force. Those functions we can evaluate over the boundary conditions, and we're gonna get the constants or those integrations. Once we get those values, we can apply those expressions for get the stresses in the beam. And finally, we can using the Hooke's law to get the strain over this point in the beam. And then these values we're gonna compare with the experimental values that the strain gauge was reading.
Analyze and discussion of the result. First, with the thickness measurements, we can say the thickness along the beam are the same, are constant, and with the plots, we can say in the strain gauge, we have the relationship between normal stress and the micro deformation are linear and directly proportional. This is because the material are in elastic zone, and also we can say with this in the points that we have the higher values of the normal stress, we have the higher values of the micro deformation or deformation. Also, the deformation is a parameter for the elongation or contractions the beam or the differential elements, and we can say with this the beam are in the tension because we have in the results higher values and positive values of the deformation.
About the error, as you can see in the following table, the strain gauge 0 has the most high values. This, for us, is because this section is closer to the clamped end, and the configuration performer in the laboratory is a simulation, but doesn't perform as a real one, allowing that this end experience small values of deflection and rotation that affect the measure. In the same way, when comparing the errors between the experimental and theoretical values for the deformation under the same force, we notice that there is a difference, which can be justified in the influence of the previous loading condition. This is all for our group. Thanks for your attention.